SMR hard drives have gotten a lot more common or unfortunately have not been labeled that well. And they do have some pretty drastic downsides at some workloads such as ZFS and anything in these intensive random writes. And since they aren't labeled well, you can't really tell. But this drive here is an SMR drive, and this one is not a conventional drive. They're both 1TB laptop drives, pretty similar. This is a newer model, and this is an older one. And it's quite hard for some models like these laptop drives to find these in non-SMR ones. So I'm going to be showing how to do a little test in FIO and Linux of how to scan to see if a drive is SMR by testing it in a workload that SMR drives are significantly worse at. And that's random writes. A traditional hard drive can write to wherever it wants on its platter, whereas an SMR drive can't, and it would have to rewrite chunks of data. And due to that, the performance is often 10 or 20 times worse than a conventional hard drive. Now this can't easily just be detected instantly when starting a workload, but you have to wait a little bit as they almost always have a small buffer that has to get filled before you notice the performance hit. Normally it takes about 5 or 10 minutes depending on the exact size of the drive. In order for testing today, I plugged this system into an older Core 2 quad system. The specs of the system it's plugged into don't really matter, as it's almost always going to be limited by the speed of the drive, not the computer. I'd even do this on like a Pentium 4 and feel fine about it. I'm running a Linux distro on it. Today I'm running Fedora. If you don't want to touch your actual system, you can run an OS off of a live disk, and it'll work just fine in there. And you can also run this on Windows with things like IOmeter or the Windows disk speed utility. I'm just using FIO today in Linux as it's what I'm most familiar with. Here's a quick summary of what all the options in this command do. I'll also put this command on screen and in the description, so it's a lot easier to find it if you want to run this yourself. So sudo in the beginning means that I'm running it as a super user, which is required for running it on the actual drive itself. More on this later. It will make sure you have permissions to do it. You need permissions to write to the file. FIO is the program we're using. It lets you do a lot of disk benchmarking of kind of arbitrary performance levels and disk sizes and workloads. Direct equals 1 makes it so that it goes directly to the disk and skips the RAM buffer. Almost every modern OS has a RAM buffer that all I/O requests go through. Direct makes sure that it will kind of skip that buffer so that it actually goes straight onto the disk, makes disk benchmarking work a lot better. Name equals smrtest is just a name that you can use. It's arbitrary, you can set it to whatever you want. Readwrite equals random write, so that will make it so that the data will randomly go on the file. So it will just kind of go one location, another location, another location. It's not sequential. This is what SMR drives are the worst at. Sequential write performance is fine on these drives, and read performance is also fine. But random write's what you're looking for. BS is block size, so that's how big the data chunks you're writing. You can go with a smaller one and see similar things, but doing 1 meg will just show you kind of worst case and also seems to work the best for this testing. iodepth is how many different requests you run at once. Some drives can optimize for multiple requests. I run it at 4. It doesn't really matter the exact amount. And filename is where you want it to write the data to. SDB is the second disk on the system. That can be found out by using lsbok. If we run lsbok, we can see it is a 1TB drive. We can also replace it with a file. So if I want it just under slash on my main drive, I can see slash test dot like FIO file. And then if I do that, I also have to put dash dash size equals whatever metric, so like 10 gigabytes. I find running on direct disk works better, but it will wipe all data on that drive you're using. So I'm going to hit run, and it's going to start, and we're going to notice iostat is going to start pumping out data. So iostat's going to immediately start saying we're writing about 78 to 80 megabytes per second, which is about what you'd expect from a hard drive, especially on a lower-end laptop drive such as this one. A higher-end desktop drive will do this a bit faster, but that's not the issue. If we wait a little bit, these speeds are going to drop very dramatically. Whereas on a CMR drive or non-SMR drive, they will stay roughly the same. So it's been roughly 10 to 15 minutes now. And the average IOPS have dropped to roughly 10, which is about a seventh of what it was before. We can see the write speed seems to kind of be going up and down, but it's going 15, and then it drops to none. And also the average wait times is about a second, it seems like. It's bouncing around, but it's roughly a second. Also, the amount of data time that it would take to finish this task has gone up from about 3 hours to about 10 hours. So that's kind of the performance issue of SMR. It goes from a normal hard drive speed, which is kind of designed for and fine, to multiple times worse, which we see right here. And it can also have much longer delays, which can often be kind of hiccups in your system, because the system is like, hey, I'm waiting for that disk to return that it wrote the data, and it won't work. So let's go take a look at what this will look like on a non-SMR drive or a CMR drive. Now, here is me running the same test on a CMR drive. Now, its performance is a bit worse, but it stays the same. And that's the main thing I'm looking for. Is the performance about the same, or does it drop off after about 5 or 10 minutes? A CMR drive will be about the same. SMR drive will have a significant drop off. You'll notice the difference. It's going to be very large if you run this test. So thanks for watching this little video on detecting SMR. Let me know if you have any questions about trying to run it on your drives. This is a fairly foolproof method for testing for SMR, as it will almost certainly have a performance decrement in this workload due to how the drive is designed.